Hello there. Right, I'm going to be as quick as I can be because I've got 25 minutes or so. So I'm a senior software engineer at MongoDB. I work on the JVM team. So I work on the Java driver and the Scala driver. Those are the kind of things that I work on. And at MongoDB, we love Spark, and we've had a long story with Spark. But personally, as a Scala developer, I learned about Spark from, you could not hear about it being a Scala developer. So my initial interest was, I heard people were using it with the Hadoop connector, so I did a little Skunkworks project last year, and that was got me interested enough to go ahead and then go and work on the big data and Apache Spark course online, which was good fun. And then we had an intern over the summer that looked at the Hadoop connector in Java and tried to connect that to Spark, and that was an interesting project. It kind of showed some of the interest that we had. And I then went on and argued that we should have a totally specific Spark connector written in Scala. I'm being a Scala guy, I love the language. So I argued and then got to work on a driver, a connector from January 2016. And it's pretty much all of it is written in Scala. I think there may be one Java file, because even if you're connecting from Java, you can actually still connect to Scala classes. You just have to write your Scala classes in the right way. It has Python and R support from Spark SQL. And as soon as I announced that we were doing it, there was loads of interest internally, and there was lots of interest externally when we started doing the beta program. So this is all about how you connect a data source, in this case MongoDB is the example, to Spark, and kind of the lessons that you learn. So the very first thing you have to learn is to understand is kind of how Spark works, and I'll very quickly go through this. It's all about having your RDDs, your data set, and then in Spark, you'll go and do some transformations, and finally, you'll do an action. In this example, we're going to do a count. And when the count happens, you'll trigger off a load of actions going on. So in this example, we're going to get some text file from HDFS. We're going to filter it. We're going to map it, cache it, filter it again, and then do the count. So the RDDs themselves are immutable. So the very minimum thing we have is the HDFS one, and then you're going to go filter it, and then that will produce a new RDD that has that as the source, and so on. So you can see, when I read a text file in RDDs, I'm going to read the whole thing in, and then you're going to do the filtering, and then you're going to do the mapping. And this becomes important later when we look at optimizing it. What happens in your Spark topology, you have to understand as well. So you'll have the Spark driver or the Spark application will be sent to that driver, and it will speak to the cluster manager, which will be Yarn or Mesos or the standalone one, to understand the health of the workers and whether the workers are ready. And then it will send off the application to go and process on the workers, and the workers will speak to the data source and give all that information back. So that's very basic kind of what happens. And then when we go and look at MongoDB and how we connect to Spark, well, before the Spark connector, everyone was doing it through the Hadoop connector. Now, I don't know if any of you have used it, but the Hadoop connector is written in Java, and the Spark connector on top of it, it was really an afterthought, and it was kind of a hard API to use. It was a Java API. It wasn't very easy. So when it came to me to write the Spark connector, I wanted to make it as idiomatic to Spark as possible. So it really got out of your way, and this is how you should write a data source connector to Spark. It really should be out of the way. It's just one part of your application and your logic. And so I made it so when you use it, you're using pretty much Spark, everything's native. It should all be, you're writing a Spark program as you wish. So when it comes to rolling your own connector, there's a few things that you need to learn and to understand. There is no documentation on this whatsoever when you go and have a look at the documentation hub. So the only thing you can do is learn from the existing connectors out there. And being open source is brilliant. There's loads. And I personally looked at the DataStax Cassandra connector, the Couchbase connector, the MemSQL connector, and the Stratio connectors as well, to try and understand the patterns and the idioms that they were using to be able to connect to Spark. So you go through, these open source libraries are your documentation, essentially. And some of them are older, from older versions of Spark, and may have some cruft that you don't need, but you really have to go and review them. And the second thing you need to do is be able to, or the first thing, sorry, you need to be able to do is connect to your data source. And this is pretty simple. And if you've got something like a database, there is some level of cost to being able to connect to a database. For example, the Spark driver wraps the MongoDB Java driver, and that runs a connection pool behind and underneath it. And that has a cost. It's going to authenticate your connections. It's going to do replica set discovery. So there's some cost to creating one. So you want to create one as little as possible. And then there's only two things you need to be able to do with your connector. You need to be able to read, and you need to be able to write. And they may be different places. They may be different databases, for example, maybe different MongoDBs. But those are the two operations that you have to do. And that's all. So to be able to do that, you need to be able to configure them. And here we have, most of them are MongoDB specific, but you need the wheres, so the URI for MongoDB, database name, and the collection name, the table name, essentially. You need to know how you're going to partition your data. And this is the crucial bit for reading, is all about partitioning. And with a document database, you don't have a distinct schema, so you need to be able to say, if your users aren't going to provide you a schema, you want some sample size that you're going to be able to use to infer the schema. And then we have some other things for MongoDB, sort of read preference, read concern, local threshold. For writing, it's all about where you're writing to. And for MongoDB, there's a write concern. You can ensure that your writes hit a number of nodes or whatever. But those are the things you need to consider. So to be able to do this, I wrote a connector class. And one of the challenges I had is things like Mongo clients from the Java driver, the connection pool essentially to MongoDB, is not serializable. So I had to have some way of being able to distribute that across to the workers so they could actually produce a Mongo client. And it's a very simple method. It's the factory. It doesn't do much, just has one method to create. And the rest of the things I have there is when you're using a database, you need to be able to speak to the table or the collection. And to be able to do that, you need a database. And to be able to do that, you need a client to it. So here, we're loaning out, using the configuration you provide, we're loaning out these things, and we're going to write some functions. And the reason we do that is to ensure that we have some sort of reference counting going on to make sure that we can clean up our resources after us. And at the bottom, we have the Mongo client cache, which is, we'll have a look at that, which is all about optimizing. So, as I mentioned, there's a cost for a database to create a connection. And to be able to minimize that cost, I want to be able to reuse the Mongo client across multiple tasks. So here, I heavily influence our cache on the Cassandra codes cache. And it's essentially a lockless cache that allows you multiple tasks to use the same client. It will keep them alive for a configurable period of time, so if one task finishes and the next task comes in and it needs to use it, it will still be there. And the nicest thing is, because we're using the loan pattern, we can close the client down properly after it's been used and no longer needed. So when it comes to making a connection, it should be as cheap as possible. And to make it cheap in Spark, you use a broadcast variable that can be shared across the worker, across tasks. And then, again, you want to promote reuse. So the connection here, we have the cache to do that. The configuration should be as flexible as possible. When I initially started, I looked at other connectors, and they were using Spark configuration, which I thought was fine. I'll go ahead and use that. And then when I went later on, I went and did data frame support. I realized that they had options, which is a map of string. So I was like, okay, so that's a different way of connecting. And then in our beta program, when people were running it on the Databricks, on the Databricks notebooks, are fantastic, you don't get the Spark configuration at all. So I realized you can't rely on that. You just want to create your own config classes that can take options of string, essentially. And by wrapping this up, I could deal with things that weren't serializable. So things like read preference from MongoDB in the Java driver is not designed to be serialized and passed across different JVMs and serialized up. So the reconfig abstracts that out. So now you have your connection to your data source. The next thing you need to be able to do is to read it. And this is where most of the complexity really comes in. Here, for example, you have a library. Your collection is all the data that's in those books, and the partitions essentially are single books. So to be able to distribute your collection, you need to be able to partition it up. And the RDD itself is a simple class that you will go and implement. And the two things you want to do is be able to partition it, and then for each partition, you need to be able to produce an iterator of whatever type it is. So for MongoDB, or a type of document, essentially. And then you can optionally provide the locations of where your data sits, if that's relevant to you. So with a sharded cluster, you know the locations. With a single node, you know where that is. So we'll come on to data locality in a while. The partition trait in Spark is extremely simple. You just have to define an index, so where your data exists in the index of your partition, so is it the first one and so on. And the MongoDB one is a case class, really simple, has the query bounds to be able to go and produce and create that partition of data. And the query bounds are the min and max ranges inside the database, so you'll do something similar. And then locations is an optional string or a sequence of strings, so the host names for where your data exists. And Spark will use these locations to determine if it has a Spark worker there, and hopefully we'll use that Spark worker to go and compute your data. Now, the complexities for me and for MongoDB is how do I partition up a collection? And it kind of really depends on how you deploy your cluster. So you can have single nodes, you can have replica sets, or you can have sharded, which are already a distributed collection of data. So the trait for partitioning is it just takes the connector that we saw earlier, it takes the reconfig, and then an optional pipeline. And this is to try and improve what RDDs don't give you is a way to push down information or transformations into your data source. I allow users who are using RDDs to be able to provide a pipeline that we can use in the aggregation framework as a kind of a speed up, so we can push less data across the wire. And that's also useful if we're doing things like with the structured API, we can also push the projections and filters into MongoDB. So when we sample, we have two main partitions that I'll show you. This is the sampling partition. This is the general use case for everything. And all this does is oversample your collection of data by a configurable partition size. So by default, you'll get 64 megabytes chunks of data. And this will use sampling. It will go and sample it, and then it'll order by the key, and then it'll get an even distribution of your data, and then it'll chunk up and take every n number. And it'll produce query bounds that look like this. And because MongoDB is a mutable data source, we decided to always add like bookends essentially to a collection. So this one, if nothing changes, this would be an empty partition that has the minimum key in MongoDB to the first item in your collection. And then you have the query bounds of your first partition, or maybe 1 to 100, and so on, all the way to the end. And then finally, we'll have the other bookend to ensure that if the data does mutate, you will get it all through. The previous one works fine for all scenarios. It will work, and it will partition up your data on modern MongoDBs. But if you have a sharded system and a sharded MongoDB, you already have partitions of your data. So MongoDB works by having in a sharded system is essentially having parts of your collection across a number of boxes. And that information is stored in the config database, so you already have those min-max chunk ranges. So you can use this partitioner instead to make sure that your data is local as possible. And again, we add the tombstone ends to either side of the partitioner. Now, there's no one size that fits all, so we also provide some other partitioners as well. These kind of depends on your use case. If you have an older version of MongoDB, you're not going to be able to use the sample partitioner. So you have things like paginate by count, which will give you 5 or 10, whatever count, number of partitions. Paginate by size will do that. And they're less efficient, but they're available. And you can also implement the trait yourself. So if you're doing date ranges and you want something different, you can do that yourself and just implement the trait, put it in your jar file, put the class path in, and then in the configs, and it will go and use that partitioner instead. So the partitions themselves, they are the foundations of your RDDs. They're really simple in terms of concept. And I say, if you have a mutable data source, it's a challenge in ensuring that people understand that it's not a snapshot in time when you go and pick out any single partition. So if they're changing the data, it's unpredictable in terms of what that will give. So a quick example of what that means under the hood, if we have Mongo Spark, which is a helper method in the connector that I use, I wrote, if you go load and then do a count, I wouldn't actually do this using Spark, it's a huge waste, but we'll create a Mongo RDD, and then we'll partition the data. So Spark, the program, will go and speak to MongoDB and calculate all those partitions, And then the workers will get a partition that will be allocated through Spark. And then for each partition, we're going to query and return the cursor. And then if we're doing a count, we're going to sum up the data and then finally return the sum of the sums. So there's multiple processes. The Spark driver will do the first thing, which will be getting the partitions, and then the workers themselves will go and gather that data themselves. The things you have to realize is all the data, everything must be serializable. So your configuration, your data that you send across must be serializable. And the partitions are the things that provide parallelism so you can actually distribute out and use multiple workers. And if no one size fits all, you should make your partitioners configurable. So if you just have a trait, make sure you can load up other people's use of it. And depending on your use case, it may be non-obvious. For a document database with thousands of different users, it is non-obvious. I can't provide one size fits all of the best one. So allow users to solve that their own way if they need to. Regarding performance, we have the MongoDB usual suspects, but the Spark ones is all about data locality, which really comes down to how you partition. So if you have a single node with MongoDB, there's no data locality available, or a replica set, you're going to speak to one or more of your nodes potentially. When it comes to a sharded system, this is where we look. We have multiple MongoDBs, we have multiple distributed system, we have multiple MongoS's that we speak through to, that we could potentially actually make this and achieve data locality. But by default, a MongoS will understand where the data is, and if you're using the sample partitioner, you may be speaking to multiple nodes. But if you're using the sharded partitioner, you can ensure and align that you use a single node, and people often park their MongoS on the same worker as well to ensure they only have one network hop. And some people go so far as having a MongoS and a hidden replica of the MongoD on the same node as well. So you want to aim for data locality if it's possible with your data source. And it kind of is with MongoDB, but it can be kind of a configuration, a little bit of a headache to be able to do that. Writing data is the next thing. So you've been able to read data. That's relatively complex because you have to partition it up. Writing data is the opposite. It's super simple. So it really is about using your connector, and then because here we're doing a data frame and we're going to save that, underneath the data frame is an RDD, which has partitions, as we've seen previously. And then for each partition, you want to, if you can do a batch save or a batch insert, then you want to be able to do that. And we can with MongoDB, thankfully. If you're using data frames or data sets, we'll also do an upsert as well. So there's some things you can do to improve performance as well. And that's pretty much it for creating a connector. That's all you have to do, read and write, pretty simple. But the thing is you really want to do is to be able to support structured data. And you'll see this throughout the conference, and we can see a huge move in Spark 1 and Spark 2 is going towards structured data. So why, with a NoSQL database, would I want to support structured data? People can ask, but each document essentially has its own schema. But when you're using Spark, and you want to use Spark efficiently and fastly, you are going to be wanting to use highly structured data. And you could make users upscale your RDDs into data sets, but the API is not terribly friendly. And so here are some of the reasons. These are all figures from the Spark survey, but structured data sets, data frames are growing in their use, and you can see they are going to continue to grow. And by supporting structured data, you also support Python and R, which is Python, and again, is another very fast-growing area of a language with Spark. It's only just behind Scala. And the performance improvements you get from doing that. And unlike RDDs, you can take the filters and the projections and pass them down to the data layer, to your data source, and apply them. So what's that really mean? Well, a data frame is a data set of row, which really is an RDD of row underneath, and a row is just a representation of your data with some optional schema as well. And data sets above and beyond that provide an efficient way to decode and encode that data. So how do you create a structured data, or how do you write something that provides it? You provide a default source. It's a strange name for a class, but this is the convention that we have. And you must provide a relation provider. So you must implement that trait. And there's a few of them. There's a default one which just says, I'll read your data source, and you'll infer the schema essentially. Or you can have one that provides a schema. So you could use a case class or a Java bean and use that as your schema, and then you will go and get data that matches that. And when you have that information, when you have that schema, you can use that to project out your fields that you have in your documents, essentially. And also, to be able to insert data from data frames into your data source, you want to implement the creatable relation provider. There is a weird trait called Datasource register. You can provide a short name for your data source. I can't see it being used anywhere, so it'll be interesting to see if that's now and should have been deprecated in 2.0, or how it's used, really. That's going on. Then there's two other things you can do as of Spark 2.0 is either become a source or a sink for a stream. And this is an area, as you saw from the keynote, is going to be continually growing. MongoDB is not a great stream source provider. You could do a couple of things. You could tail the op log or tail a cap collection, for example. But definitely a sink for a stream, that's pretty easy to do. You implement the trait, and away you go. When it comes to inferring a schema, you can either provide a schema and use some of Spark's own the library that Spark has a reflection for a case class or reflection for a Java bean, and say, like, turn this into a struct type for me, and you can use that. Alternatively, with MongoDB, and for people in Python and R, they're not going to be able to provide these things. So we sample the collection, and it's pretty simple. By default, we sample 1,000 documents. That's configurable. And we turn our data into a struct type. And the biggest challenge we have is unsupported types. So we use an extended format that we use when we produce JSON and actually have an extended struct type as well underneath. And we would like to use the user-defined types, and hopefully they'll come back in Spark 2 as they went private initially. And then we use the tree aggregate function to go and find the compatible types. And if you have conflicting types, which is often the case with a document database, or can be the case, then we'll default down to a base type, which will be string, which is the same as how the JSON library works as well. And then finally, you have to provide your provider, which will give you a base relation, essentially. And there are multiple traits that you can do here. A table trait will return all your data, so this is similar to an RDD. The prune trait will just be select some columns, so you'll do a select ID field, select name field, and you can use that data to actually transmit less data across the wire in your connector. And the filtered scan as well will allow you to filter out columns, so that will have a where clause, essentially. There is a catalyst scan as well, and that's experimental. I can't see the benefits at the moment of using that over the pre-filtered. So the pre-filtered is easy to understand. And you also have an insertable relation as well. So that allows you to do select and insert into. And the benefits of doing this is you get multi-language support out the box, really. So all you have to do is in the format part, you give the class path to where the default source is. And you don't have to have default source. It's a convention that it'll append it to the end. So here we go, using 3 different languages and using your Scala code, you can connect into them easily and efficiently. So when it comes to rolling your own connector, the first thing you should do is review the existing connectors, look at how they work. There's no documentation, as I say, so they are your documentation. Go and speak to them, the users. Open source is a brilliant thing, so go do that. Partitioning may be the trickiest part, because it is for a mutable collection, or if there's no easy way to do it. So for a collection on a single box for MongoDB, that is the part that has the most knobs, essentially, to configure and has the most flexibility. Default source, providing a default source or a relation provider opens the door to other languages pretty much for free, so it's really easy to support Python and R. Schema inference is the biggest source of pain for document databases because users use document databases to have multiple or divergent schemas, essentially. But having structured data really is the most important part for being able to have, and it really is the future for speedy Spark. So ensure that you do support it. If you're interested in MongoDB and Spark, we have an online course available at the MongoDB University. It's free, self-paced, so please go and have a look at that. And For questions, please come and see us at the booth. Thank you very much.
Thank you, Ross.